we are starting off with this fun AP problem. What? Yeah, right by you, champ. You better not say anything inappropriate.
Oh, you won't hear me.
They will. Okay. You say carrots?
Yep, that's what she is. Yep, that's what she is.
I want me to line this really quick. Oh my gosh. Who wants to read this beautiful problem? Thank you, Emily. What? Okay, go ahead. What did you say? Go ahead and read this beautiful problem. Okay.
The temperature of water in a tub at time is followed by a strongly increasing twice differential function W, where WT is measured in degrees Fahrenheit and T is measured in minutes.
Hey, pause. So let's kind of pull out the information we want to take from that sentence. And you can use your pencil, a highlighter, whatever. Okay. Just go away. Okay. So my highlighter is, I'm going to say I am strictly increasing. Okay. I am differentiable. That's good to know. And I am in degrees Fahrenheit and minutes. So that's the first information I would pull out. Okay, so is W of T, is that kind of like a position, a velocity, an acceleration? What is that? If it's only measured in like Fahrenheit, right? It's more like the position of the temperature. Okay? So this is our position. It's not a rate, is what I'm saying. This is just the basic position function. It's the position of where the temperature is. Okay. Alright, unpause.
At time T equals 0, the temperature of the water is 55 degrees Fahrenheit.
Pause. Okay. So now we just got a point. I'm going to come over here and I'm going to say I have my time and I have my W of T, right? What's my point that they gave me so far? 0.55. Okay, unpause.
The water is heated for 30 minutes beginning at time T equals 0. The values of W of T at selected times T for the first 20 minutes are given in the table below.
Okay, so here now we're given this table, selected times between 0 to 20, and again, W of T is just the position, right? Okay, how could I find the velocity? How fast the temperature is changing? I could take the derivative of. Okay, so W prime of T would be talking about the derivative or the velocity, how fast it's changing. How do we measure W of T? What's that going to be measured in? Degrees Fahrenheit per minute. Agreed? And that's talking about how fast the temperature is changing with respect to time. What would W double prime of T be talking about? Okay, so that would be in degrees Fahrenheit, minutes squared, and that would be an acceleration, so how fast the rate is changing. Okay? Yes, kind of? Okay, so let's go look at A now. Is that kind of background okay for what's going on in this problem? Are you so excited to understand the temperature in a tub? They give you some really weird things on here. You'll be like, what if what that was like cookies? I don't know. Tea, cookies. Okay, anyway. So, pause.
Use the data in the table to estimate W prime of 12. Show the computations that led you to your answer using the correct units and interpret the meaning of your answer in the context of this problem.
Okay, so pause. Go see if you can do part A. I think you can. That was several of these. W to actually go find W prime? No. So we're going to have to go up to the table. We're going to use the slope of the secant to approximate that tangent, right? Everybody know what I'm talking about, or is anybody lost? Raise your hand if you're lost. 12 is in between those two. So W prime of 12 is going to equal approximately, right? W of 12 minus, sorry, W of, we had 15 minus W of 9 over 15 minus 9. Is that enough information for AP? No, because we still have the W's. Okay, so again, we said that guy is going to be equal to W of 15 is that enough for AP? Yes. Okay. If you want to simplify it, great. Now, for just like W prime of 12, I would stop. So that would be the first part of it. I kind of banked that. Now I'm going to go on to the second part of A, and I'm going to go ahead and simplify this. Okay? And you may use a calculator. Okay, so what did we get out? Okay. And can we go ahead and label this? This might help us. Okay, this would be what? Yeah, degrees Fahrenheit per minute. Okay. Now it says, though, interpret the meaning of your answer. And the reason that I would go ahead and simplify this is kind of like to put it over 1. So it's easy to see, like when I go to talk about it, that for every 1 minute, right, I'm increasing how much? Instantaneously. That amount, okay? So see if you can write what that would be, the interpretation. Try to struggle through, and then I'll write what I put. And you can fix or justify or whatever you need to do. place as an AP grader, and it will be counted with the correct units. Okay? But if you didn't label it here, then you have to put the units here. Does that make sense? Okay, so either way, but you also have to tell me at time equals 12. If you don't have that piece, and that piece, you didn't get the answer. Okay? Questions over that? So, okay with everyone? Isabel? Yeah, you started. Okay. Alright, so let's look at the next one. Now this one is actually one that we kind of get to, but do you want to talk about it or you want to skip it for now? Because it's got the integral. Skip it for now? Okay, that's fine. It's not too bad, but it has to do with stuff we haven't got to, but I know you kind of looked at it. So let's go look at the next one because that's the one I really, really want to focus on. A was kind of review. Okay, so unpause.
For T being greater than or equal to 0 and less than or equal to 20, the average temperature of the water in the tub is that.
Use a left answer.
With the 4 subintervals indicated by the data in the table to approximate that. Does this approximation overestimate or underestimate the average temperature of the water over these 20 minutes?
Okay, so we want to go and estimate using what was given in the table. And do you remember what I always try to do once I see a table? Yeah, I make a quick little graph. To me, it's just easier. Okay? But again, that's kind of up to you. And it's telling me I'm going to have 4 subintervals. Again, I don't care about the tick marks, I just care that they're in order. They would make that easy, everything in guessing order. Told me I was going to have 4 subintervals, and I'm going from the 0 to 20. Right? Here I can see my 0 to my 20. And I need 4 subintervals. So I have this one going on, this one going on, this one going on. There's 3. And now there's 4. So there's where my 4 subintervals are. And it said a left Riemann zone, so I'm starting from the left and coming over when you're in that interval. So let's go and get the areas. So this area is 4 times 55 plus this area. What's that with? 5 times the height of 57.1 plus this area 6 times 61.8 don't have to go simplify that. If you want to, great, you can put it in. But what did this estimate? This is the trickier part. This was the approximation for what? It is an under approximation, right? Okay, because it told me I was increasing. But this was for this W of t. What did they throw on in front that they want us to also use? 1 over 20. Okay, what we just found didn't include the 1 over 20. Okay? So if I put in over here, if I put in a 1 over 20, guess what I have to do to all of that? Divide by 20. Now you've banked that first 2 points. This is over 3 points. And now you have banked the first 2 points. Now, if you guys want to simplify that and spend the time on it and possibly make a mistake, not me. I'm going to leave it like that if I'm an AP tester. Okay? Little testing tip. Okay, so let's do the next part. I kind of already talked about it. Sorry. But it wants to know, does this approximation over or underestimate? And when we do left and right, we talked about this yesterday. Go write your justification for me. And it's really, really short and simple. Justification. It's very short and simple. But what it is and why. And the why is because this really, really fast. Laura, what'd you put?
Mine had it's underestimated because we want some to see the area below the curve.
Not always. Because it's a left Riemann sum on a what? On a decreasing or increasing? Increasing. Okay, so if we're kind of writing how Laura was writing it, that's what you could say. How many of you said underestimate because W of t is increasing? Full points. Okay? So that's good. Boom. That gives you full points, and that is interesting. Okay? And again, D we'll worry about later. I really wanted to do those 2 things. Okay, so just looking at this, where do you think common points are missed? Where do you think is one of the most common points? People will forget to explain. Did it ask us to explain this? Oh, up here. Yes, people forget to explain up here. Sorry. The interpretation, you mean?
Yeah.
Okay, yeah. So the interpretation, but on part C, where do you think they always miss their points?
Divide by 20.
Dividing by 20. Okay? So this right here, getting it in there, is where a lot of points are missed. Okay? And they may have you interpret this even. Could you interpret what this means? That's okay. We'll get to it more. Okay? Right now I just want to make sure we can do the Riemann sum. Once we get to the integrals, we'll be able to interpret it more. Okay? But not too bad. first see it, you just want to be like, oh, but it's not too bad. And the rest aren't too bad either, once you know a little bit more chapter. Okay, so we already talked about we don't have to have equal widths going on. They could be unequal, and that's what we just did. Okay. So this next part, if you guys can kind of bear with me, this is new in the curriculum this year. You're going to have one of these on your multiple choice, hands down, because it's new in the curriculum this year. Okay? So you're going to have one like this. So here it's just saying that we can rewrite the integral as a limit function of a summation. So you guys have all seen the summation function before. We're going to do a lot of summations in BC. So much fun. Okay? But, so here it's just saying that the width is going to 0, or the number of intervals that you have is going to infinity. And sometimes you could see like n, sometimes you could see k, sometimes you could see i's. Like they can switch up the variables on you, and that's not a big deal. You can kind of put variables in. Okay? Okay, so we're going to do this process. We're going to rewrite this guy right here as a limit of a related sums, Riemann sums. Okay? And this is how they're going to use the wording, the related Riemann sums. So the first thing we're going to go do is find our delta x. We've kind of already been doing this yesterday. How did we go find it? We took b minus a over n, right? So in our case, what's our b? 10 minus what's our a? 4. Do we know the n? So we're going to leave it n. So we have that part. Okay, then we're going to kind of just see if we keep getting more and more and more and more intervals, what that's going to look like. So basically, like if I start at x of 1, it means I start at my a, and then I would go as much as I added on. That's 6 over n. So this right here is my a, okay, plus my delta x. So this is going to be our step 2. We're going to see the pattern. So then what's the next x value going to be? Well, we're going to take what we just got, and then what are we going to add on to it? To get to the next spot, 6 over n. It's kind of what we were doing yesterday, so let's just kind of review a little bit. So I was going from maybe 0 to 2, and I wanted 4 sub-intervals, okay? So we would do 2 minus 0 over 4, and we said 1/2 was our delta x. So we go 1/2, and then how do we get to the next one? I would take where I'm at plus 1/2 and get to 1. So that's where we're at plus the next part. And then how do we get to the next one? Where we're at plus 1/2, and we'd be at 3/2. So that's all this is kind of showing us. So simplified here, this would be 4 plus 2 times 6 over n. So now this is kind of like, okay, the first one we are at maybe this. We started, sorry, at 4. Let's do that. So we started at 4, and then we went to 4 plus some 6 over n, basically. And then our next one is going to be at 4 plus twice the 6 over n. Where's our next one going to be? 6 over n, plus we're going to add on another delta x to get to the next spot. So that's plus 6 over n. Or 4 plus 3 times 6 over n. So that's going to be where the next one is. Is this making sense at all to you? Yeah, okay. That's really fine. Okay, so in general, find your x of n. Okay, because we don't know how many n's we're going to do. So in general, what would we do for any n? Or let's actually, we've already used n, so let's make it x of I. Sorry about that. We've already got n going on there. Oops. Okay, so that's our step 2 is kind of seeing what we're going to be adding on. Oops. So then in step 3, we're going to look and say, well, what was our f of x? And up here, what was our f of x? It was 6. Okay? So once we get our f of x, we want to find f of x sub I. So we're going to take this guy right here and plug it in, oops, sorry, for x sub I. So we are looking for f of 4 plus I times 6 over n. So it's just a function composition. Well, no matter what I plug into our f of x, right, what do we always get out in this case? 6. Okay, so that one wasn't very much fun. So we get out 6. So then our last step is we're going to go back to that limit definition here. So we have the limit as n goes to infinity, the summation, I equals 1 to n of f of x sub I times delta x sub I. And we're going to plug in what we found. Yes. How did you get 6? Because no matter what I plug in, like, let's say, what's f of 1? Oh, 6. What's f of 2? 6. So f of some weird thing is still 6. Yeah. So this becomes the limit as n goes to infinity of the sum from I equals 1 to n. And we just found that f of x sub I is going to be 6 times our delta x sub I, which we found was 6 over n. That is our final answer. Okay? So that's the integral kind of written as a Riemann sum, a related Riemann sum. We're going to try another one. Kind of do the process again. Okay. So now I just don't have a constant. That's kind of nice. Again, it's procedural. If you like steps, it's a step process. Okay? It's not a lot of thinking if you just follow the steps. Just like steps. Give you step 1. Oh yeah, not too bad, right? am I going too fast? Call me, don't look up until you're done. Everybody got step one? Step two. Where am I starting? I start at -1, and I'm going to add on. What's that? 2 over n. The next one. Yeah, so we're kind of seeing we're going to add 2 of those on now. In general, what's x? What do you want to call this one again? I, k. You want to use a different letter? You like a I? Okay. I. Usually it's I or k when dealing with summations. So that would be -1 plus I times 2 over n. Okay. Step 3. What's f of x? X cubed. So now we want to find x of what? Yeah. So what would that equal? So we're going to use this guy to help us with this, right? So what would that be? It's just that guy plugged in for x, right? So it would be that guy cubed. Okay. What if I had just, so that's f of x. What if I said, what's f of 2? What would you guys do? 2 cubed, right? What if I said, what's f of x plus 1? It's the quantity x plus 1 cubed. So all we're doing is taking that blob and plugging it into our x. So that's just like we were doing here. That's where this came from. It's just a composition, but it's a weird blob. Okay? And then the last step is now writing it. Limit as n goes to infinity. The summation. You guys already done. Sam, you got it. Huh? Yeah. Okay. Keep going. Tell me what the hell. You said you got it.
You know what I
Yeah, I've got it. I think they got it. Try it. Yeah. It's okay. It's really got it. Yeah. So we use I. Starts at 1, goes to n. We're going to do our f of x sub I, which was -1 plus I times 2 over n, that whole quantity cubed, times our delta x sub I, which we said was 2 over n. And that's our answer.
not what you have to say.
Line there, and there's clearly benefits to saying
Okay. So this was taken from an AP question that they gave us to kind of like prep you guys. Okay. And let's see if we can see what's going on. There's really only two numbers, and I can tell you the answer. Okay? From just the two numbers. Look right here. What does that value have to be right here? The starting. That's our A. So where do I have to start? Well, that one didn't start there. Okay, so I can get rid of it. Agreed? What about this right here? From the 4 over n. Okay, so I know that B minus A, right, has to equal that 4. And we already know our A. So what's our B have to be? 7. Okay. So I can get rid of that guy. Yes? What's this for? What's that all about? Any ideas? I just see a function squared. Did I have any idea what that for is? That was just some distractor. So what's our answer? Right here. Now, this would have been appropriate if they would have also have had a 4 out front of the parentheses. But I didn't have that. Okay, so my function wasn't 4x squared, my function was just x squared. Is that okay? You able to do that on your test? It's not too bad when you do it this way. Okay. So that was the newer stuff. Kind of fun. Did I do okay with it? By the way? Is that okay? Oh, that was it. Yeah, I've never taught that before. We did that on math. Okay. That's my first time. Yeah, it was new in the curriculum. I wanted to make sure I did okay.
okay, did
Okay, so this is just a reminder for you, just to kind of help make sure you remember, okay, as we kind of keep going with the differentiable and continuity. But, okay. So let's look at this guy. Remember about this the other way. And then we're going to kind of start into the next section of this. But so this guy is it's integral. And oh my gosh. Integrable on -1 to 1, but it's discontinuous at 0. So because it looks like, you guys remember what that looks like? A little bit. Right? So I can integrate at everywhere except for the 0. Okay? So at 0 is the only place that I can't get that because it's discontinuous. But I can integrate everywhere else. Okay? Anyway, that's I'm not too concerned about that. But so we're gonna look here. I want you guys just to put this into your calculators and give me the answer. And if you have an 89, raise your hand if you have an 89. Okay, so let's do 89. So we're going to go math. If you don't have the 89, I actually can show you which things. but go to your math. So go home. Go math. F3. Sorry. What did that say? Yeah. Okay, F3. I don't know. I thought it was math for a second. So go F3. Go integrate. So then you have, with your open parenthesis, you're going to write in your function. And then you're going to say with respect to x. And then you're going to go from -3 to 1 and close your parenthesis. So that's on the 89. Okay, how many of you guys have the 84? That's where you go to math. Sorry. Okay, so the 84, you go to math. And I can show you. Here's my TI. Okay, so math, and then we go again to the integrate, which is 9, and fill in everything basically. I wish they could combine the 84 and the 89s together. Like all the pretty friends of the 84s and the 89s. Okay? So what did you guys get out? Did everybody get 8? Yep. So let's go back now and let's graph this from -3 to 1, from our A to our B here. So I want you to show me the graph of this from -3 to 1. Let's do that again. Let's see, at -3, where are we at? -6 plus 4, so -2. -2, we are at 0. -1, 2, 1, 0. Okay, so we have this graph. And we want to find the area, okay, which is that integral. So I'm going to see what is this area, what is this area. If it's above the x-axis, the area is what? Positive or negative? Positive. If it's below the x-axis, that area is going to be negative. So let's go find those. And this is just a triangle. We can find the area of a triangle. One half base side. So let's see. 1, 2, 3, 4, 5, 6 times 1, 1, 2, 3 divided by 2. So 3 times 3, 9. So you guys got? And then what about this one? 1 times 2 divided by 2 is 1. And it's going to be under the curve, so I have -1. So the total area, right, would be that integral from -3 to 1 of 2x plus 4. And again, what do I see it's going to be when I put them together? 8. Positive 9 minus 1 is still 8. That's what your calculator was doing. Now looking, somebody one more time on that, I'm sorry. if I took and dropped it down like some amount right here, drop this right here, can I still find the area? Yes. Okay? So I can still find that area even though it's discontinuous there. We can still get a bounded area. Okay? So that's what we're going to kind of look today. It's just with graphing simple shapes and finding the area. And we talked about that. If you go from the same amount here, from A to A, have you covered anything? So that's 0. And here, if you flip-flop A and B, you negate. These guys are going to show up a lot and will help. Okay? So get these down in your flashcards. And then the third one that's pretty important is if you go from A to B, you can pick any C value to break it up. So like let's say that I went 0 to 5. I could break that up and go 0 to 2 plus 2 to 5. Sure. I could break it up and go 0 to -3, even though it's not in the interval, doesn't matter. Plus, where do I have to start now though? -3 to 5. So we can break up this guy with any C value as long as it's the same. And we're still going to get the equivalent amount. Because sometimes they're going to give us information and we're going to have to rearrange, and it's like a puzzle. Yeah. And sometimes we want to break it up anyway just because some of the areas above the x-axis and some is below. So we can see what's above, what's below. Okay. These guys are just pretty basic. I'm not too worried about it. Okay. Okay, so we're going to do one more page and we're done. Well, one page and one problem. 4 more problems. Okay, sorry. Okay, so let's look at this. Sketch that out for me of what that is asking you to find. Everybody get that? So again, we're going to drop it down to the x-axis, and we are looking for this area. So this integral from -4 to 4 of the absolute value is actually equal to the integral from -1 until what? 2. And what if I take away the absolute value, it would end up being, that's the negative slope, right? So that would be like the negative of x minus 1.
Wait, how is it? I thought it was.
What?
Like,
Is it 1?
yeah.
Okay, sorry. Thank you. I was looking excited. Yeah, thank you. From 1. And then I can start up at 1 and go to 4 of that positive. So I can split up intervals. Well, it's pretty easy though, just to get this picture. It's all straight lines. All above, so this side's going to be positive. This is above, so that guy's going to be positive. How much is this one? 1, 2 times 1, 2 is 4. Divided by 2 is 2. How much is that one? What would you say? 9 over 2? 1, 2, 3 times 2, 3, 4. Are you sure?
That's 3, like 4.
1, 2, 3,
4, 3.
2. From right here? 1, 2, 3, 4. Did I go to 3?
There's only 3.
Oh, got it. 3. 3 times 3. 9 over 2. Okay. Man, DeRose. So total, what do I get out? That guy would also equal, and what would you get? 13 over 2. Okay. Okay, let's look at this one. What does that plus 5 mean to you? Okay, we're just going to add 5 to our answer. So go find that, and then add 5. Go. First one done, now pop rocks. Except for Matt's side. He's excluded from this competition. Tropical punch. Pop rocks. Taste the flavor. Taste the explosion. Ooh. You know you want them. But for no pressure. No pressure. Take your time, no pressure. No pressure. No pressure. Got a little trapezoid going on? Got an answer? No. No. No, you can't split twice.
That wasn't a rule.
I just added it. Wait, but you do? Are you sure? Oh, Laura? Laura? No. Colleen?
wrong, but that's not covered.
30 more seconds. We're dropping this one. You got the whole box?
How much?
Yes, he's done. Hold on. Guys, yes, he's done.
No, he already spent it. 5.
You got wrong? You got right.
6. 7. 8. 9. 10. Are you ready to go? Not saying, but he was excluded. So, who's next? He would have got it. Position on my clock. Where am I at? 15. 16. Where's 3 at? 6, 7, 8, 9.
You're real good now. I got 18.
Mr. Rose is the winner. I guess I get. Okay, what questions do you have?
Next. That is enough.
Alright. Alright, let's see. We'll do another competition. 9. I'll give you a little hint before we start, okay? I'll help you out. You want to break this guy up. Just like when we did derivatives, the pluses can be broken up, right? So they can also be an integration. So I can break it apart right there. Okay? That's my hint. Now I'll let you go. Still dishing on my pop rocks, Matt thing? Still dishing.
My grandma says party.
Hey, this gives you guys more time. Distracted up here. You guys get to the prize of the pop rocks. Taste the explosion. What do you think is the first ingredient?
Pop rocks.
Sugar.
That's what it is.
Processed carbon dioxide. Guess where's Spain?
US of A. Indonesia. Vietnam.
Germany.
Distracting all of you. It's gonna get it.
Mexico. Caribbean. Antarctica. Sweden. Norway. Russia. Switzerland.
Oh, anybody want to try?
Oh.
Ooh, Alec. Pop rock winner!
Oh, yeah, baby.
Okay.
Atlanta, Georgia.
Spain.
Oh, Spain. What's Spain?
Oh, well, it's made in Spain. It's distributed.
Okay. Alright, so, Alec, how did you do this? Take us through.
Well, it tells you that the first chunk is equal to 3.
That one right there.
Yeah, you can plug that in and multiply by 2. And then,
Is that okay with everyone? Okay.
since it's like this, it says 40x, you know, the x is 4. So, the graph is just a horizontal line. Yeah.
Like that? So then the area I'm looking for is this.
That's 1 plus 4.
1 times 4, which is, and is it positive or negative?
Positive.
Because it is
Above.
B. which gives me a total of 10. Okay. Last one. Want to repop competition? This one's kind of like the puzzle, Emily.
I'm excited.
That was my hint. What I got?
I didn't mean to.
Okay, this competition is for a super star
She's got like a lot of like
pencil sharpener. And it will remind you every day that you are a superstar in calculus.
It's only like one person gets that. We're all sucking it.
It is a gold star. Let's go. Figure out the puzzle.
You don't get to play the game.
Hey, open those up. I want to try one. I haven't tried one.
One power is changeable.
I haven't tried them in a while. I want to remember what the fizzy in my mouth tastes like.
That's 50 action.
That's a feeling.
New fit. 5%. Rock. Rather than
Here,
salt.
I'm ready.
That has got to be so cool.
Ow.
Try it.
Ow.
What you got?
I get
Who wants to try?
Pencil sharpener would be so nice to have since I have wooden pencils.
Anybody?
Exactly.
Bueller?
Oh wait.
Are you submitting?
Yeah.
Figure out the puzzle?
Gosh darn it.
10,
Darn.
9, 8. You submitting? What?
Yes.
It's not a sticker. It's a pencil sharpener. This is superstar.
I would like to show you this.
7, 6, 5, 4. Jack? Almost. Be very sure you're writing over there. 3. Anyone?
It's 2.
2.
Is the answer?
1. Any submissions?
Excellent.
All right. What do you got?
2.
2 is correct.
Thank you.
Okay. So let's look at this. This was the first part that they gave me. So guess what I would do right away? Multiply both sides by 2. Okay, so I know that the integral from 1 to 3 of f of x dx, oopsie, oh gosh, gross. Those should have dx's. Okay, equals 6. Okay, that's the first part I'm going to go. Then they also told me that the integral from 2 to 3 of f of x dx equals 4. Nothing really crazy to do there. They want me to find the integral from 1 to 2. So let's break it up. I could go 1, 2, 3, and then 3, 2, 2. Does that make sense? So those just have to match. This guy and this guy have to match. So basically we have went 1 to 2. Well, 1 to 3 we know is 6. But we don't know 3 to 2. We know 2 to 3. So 3 to 2, what do I do with that number? When we flip-flop, we negate it. Okay, so 3 to 2 would be the negative 4 for a final answer of 2. So we got to use all kinds of fun little properties. Yes?
Did you just know that, like, the 1 to 3 one is 6, and then set that equal to 4 plus, like, a variable if it's off for different?
Sure. Yes. That's where we're going to figure out.